Good morning students, welcome to today's chemistry class. In the previous class we have studied about the electronic configuration of metals and non-metals. Now we can study what is the reaction between metals and non-metals. What will happen if metals react with non-metals. Okay. As an example for metal and non-metal we can take sodium and chlorine. Sodium is a metal and chlorine is a non-metal. And what will happen if they are combining with each other? Already we have studied that when these metals, they contain either 1, 2 or 3 electrons in their last shell, and they have a tendency to lose these electrons when they are combining with other atoms. Like that, in the case of non-metals, they contain 5, 6 or 7 electrons in their valence shell, and they have a tendency to accept electrons in order to attain stability, isn't it? So metals have a tendency to lose electrons and non-metals have a tendency to gain electrons. So here when a metal combines with non-metal, what will happen? Metal is giving its electron to the non-metal, and as a result non-metal is accepting those electrons. Okay, that we can show diagrammatically by taking the example of sodium and chlorine. Its symbol is Na, and the sodium contains 11 electrons. Its atomic number is 11. Its electronic configuration can be written like this: 2, 8, 1. That means it contains 1 electron in the valence shell. And it has a tendency to lose this 1 electron, isn't it? So when we are showing the structure of sodium, we can show only this last electron present in the valence shell. Okay. Instead of drawing all the structure of atoms, sodium atom, we can draw only the last electron present in the sodium atom. So we can write like this. First we have to write the symbol. Then we have to show that last electron as a dot. This represents the electron dot structure of sodium. Electron dot structure of sodium. Okay. So here sodium atom contains 1 electron in the last shell. Then what about chlorine? Chlorine, the atomic number is 17. So its electronic configuration is 287. It contains 7 electrons in the last shell. It requires only 1 more electron, isn't it? And how can we show the electrons in the chlorine atom? For our convenience, we are drawing only these 7 electrons present in the chlorine atom. So first we can write the symbol of chlorine, and to show the 7 electrons, either we can use 7 dot or we can use 7 crosses. Okay. So in order to distinguish between the electron of sodium and electrons of chlorine, we can use or we can represent the electrons of chlorine as crosses. 7 electrons that we can represent as crosses. Got that? This is known as the electron dot structure of chlorine. Okay. Now when sodium and chlorine combine together, what will happen? Since sodium has a tendency to lose this electron and chlorine has a tendency to gain electron, sodium will give this electron to the chlorine atom, or this electron is transferring from sodium to chlorine. And as a result, what will happen? Since sodium is losing this 1 electron, it is getting 1 positive charge. So that we can represent like this, Na plus. It is getting 1 positive charge, that we can represent like this. And what will happen to this chlorine? It is gaining 1 electron. So it is getting 1 negative charge. Now we can write the symbol of chlorine, and it already contains 7 electrons, its own electrons, isn't it? 7 electrons plus 1 electron it got from the sodium. So it is getting 8 electrons. As a result, it can attain stability. Okay. Now, since it is gaining 1 electron, it is getting 1 negative charge, that we can represent like this. Put this in bracket, and outside the bracket we can put 1 negative charge. Clear that in. So here in this compound, do we want to draw the electron again in sodium? No. Sodium already lost its electron, so no need of drawing this electron there. Okay. Since it is losing electron, it is getting 1 positive charge. And here in this compound, sodium contains a positive charge and chlorine contains a negative charge. And we know that these positive and negative charges are attracting each other. So there will be a force of attraction between this positively charged sodium and negatively charged chlorine. As a result, they remain together. They will attract each other, resulting in the formation of a new compound that is known as sodium chloride or NaCl. Okay. So when sodium combines with chlorine, we will get sodium chloride, NaCl. And how the sodium chloride is formed? It is formed by the transfer of electron from the sodium atom to the chlorine atom. Okay. By transferring this electron, sodium is getting one positive charge and chlorine is getting one negative charge, and there will be a force of attraction between this positive and negative charge, that resulting in the formation of this compound sodium chloride. And since the sodium chloride contains a positive ion and a negative ion, this compound formed here is known as an ionic compound. So sodium chloride is known as an ionic compound because it contains ions, a positively charged ion and a negatively charged ion. So how can we define ionic compound? Ionic compounds are the compounds formed by the transfer of electron from this metal to a non-metal. Okay. So this is one example of an ionic compound. Then what changes occurring to sodium during the formation of sodium chloride? Sodium, it is losing its electron. Sodium is losing its one electron and changing into Na plus ion. Isn't it? Sodium is losing one electron and changing into Na plus ion. This thing we can write here. That is, this electron we can take into this side. So how it will change? It becomes Na plus one electron. Okay. This shows that sodium is losing one electron and changing into Na plus ion. Like that, what will happen to chlorine? Chlorine is gaining one electron. So how can we show that? Chlorine is gaining one electron and changing into Cl minus. Chlorine is gaining one electron and changing into Cl minus. Okay. So this positively and negatively charged ions are attracting each other, resulting in the formation of a compound sodium chloride. Clear? Now we can study another example, that is the reaction between magnesium and oxygen. We know that magnesium is a metal and oxygen is a non-metal. So if magnesium and oxygen combine together, magnesium has a tendency to lose its electron and oxygen has a tendency to gain these electrons. Okay, so we can show how this transfer of electron taking place between magnesium and oxygen. Okay, then magnesium, what is the atomic number? 12. So how can we write the electronic configuration? 2, 8, 2. That is the electronic configuration of magnesium. It is combining with oxygen. Its atomic number is 8 and the electronic configuration we can write 2, 6. So here magnesium contains 2 electrons in the last shell and it has a tendency to lose this electron in order to attain stable configuration. Like that, in the case of oxygen, it contains 6 electrons in the last shell. So it has a tendency to gain 2 more electrons to attain stable configuration. So when they are combining with each other, magnesium is giving these 2 electrons to oxygen and as a result, both of them can attain stability. Okay. Now we can show that diagrammatically. So first we have to write the symbol of magnesium Mg. And all these electrons we are not showing in this. For our convenience, we are showing only the last 2 electrons present in the valence shell. And these 2 electrons are expressing as a dots. These 2 electrons are represented as dots. Okay. So since magnesium contains 2 electrons in the valence shell, here we can put 2 dots. This is known as the electron dot structure of magnesium. Okay. Now, how can we show the electron dot structure of oxygen? First, we have to write the symbol of oxygen, that is O. And how many electrons are there in the last shell? 6 electrons. When we are writing the electron dot structure, we are representing only the electrons present in the valence shell. In the case of oxygen, it contains 6 electrons in the valence shell. So here we have to draw 6 electrons. Okay. Then to distinguish the electrons of magnesium from the electrons of oxygen, here instead of dot we can use crosses. Okay. So 6 electrons are there in the valence shell of oxygen atom that we can show as dots. Okay. Now when they are combining with each other, what will happen? Magnesium is transferring, or magnesium is giving this electron to oxygen atom. So to show that transfer of electron, we have to draw an arrow like this. Okay. Magnesium is losing 2 electrons to the oxygen atom. Clear? Now what will happen? Here magnesium is losing these 2 electrons and as a result it will get 2 positive charge. If an atom is losing electron, it will get positive charge depending upon the number of electrons lost. Here magnesium is losing 2 electrons, so it will get 2 positive charge that we can represent like this, Mg2 plus. Okay. Since magnesium is losing these 2 electrons, it is getting 2 positive charge. And oxygen is gaining 2 electrons. As a result, it will get 2 negative charge. How can we represent it? First, we have to write the symbol of oxygen. Then it already contains 6 electrons. Those 6 electrons we have to draw here. Okay. 6 crosses we have to put. Then 2 electrons it is getting from magnesium atom. Those 2 electrons we have to draw as dots itself. Okay. Then here oxygen is getting total 8 electrons. As a result, it can attain stability. Then since it is gaining electron, it is getting 2 negative charge that we can represent like this, 2 minus. Okay. So here it contains 2 positive Mg2 plus ion and O2 minus ion. Both are oppositely charged, so they will attract each other, resulting in the formation of a compound magnesium oxide. Okay, and its formula is MgO. And since it contains ions, this magnesium oxide can be called as an ionic compound. Okay, now how can we express the losing and gaining of electrons? How can we write the equations? First, we can write about magnesium. We know that magnesium is losing electrons, isn't it? Losing of electrons we can represent in the product side. How many electrons an atom is losing, that we can express in the product side. Here magnesium is losing 2 electrons and it is changing into Mg2 plus. So here we can write Mg2 plus 2 electron. This means that magnesium is losing 2 electrons and changing into Mg2 plus. Okay. Now, what is happening to oxygen? Oxygen, it is gaining 2 electron. That gaining electron we can express in the reactant side. So, here we can write 2 minus. O plus 2 minus giving O2 minus. Okay. So, this is the equation to show the transfer of electrons. Clear that? So, when we are asked to write the formation of magnesium oxide, we have to write all these steps. Then only we will get full mark. Okay. So already we have studied that ionic compounds, they are formed by the transfer of electron from a metal to non-metal. So the definition we can write like this. Ionic compounds are formed, the compounds formed by the transfer of electron from metal to non-metal are known as ionic compounds, and these ionic compounds are also known as electrovalent compounds. Next we have to study about the physical properties of these ionic compounds. First, we have to study about their physical nature. What do you mean by physical nature? Whether they are existing as solid, liquid or gas. Already we have studied that these ionic compounds are formed by the force of attraction between positive and negative ions, isn't it? And this force of attraction is known as electrostatic force of attraction, and it is a very strong force of attraction. So here in the case of ionic compounds, due to the strong force of attraction between this positive and negative ion, these ions are very closely packed without any space between them. And if the particles are very closely packed, that the physical state of that substance will be solid, isn't it? That already we have studied. If there is large space between the particles, that will be a gas. But here the particles, that is the ions, are very closely packed. That means the physical state of these compounds will be solid. Okay. And since these particles are, since these ions are very closely packed without any space between them, we cannot compress them. We cannot compress these ionic compounds because there is no space in between the particles. So we can tell that these ionic compounds are hard solids. Okay. Then the next property we have to study is their melting and boiling point. What do you mean by melting? Melting means a solid substance is changing into liquid by heating, isn't it? That process is known as melting, and the temperature at which this process takes place is known as melting point. Okay. So a solid is changing into liquid at its melting point. Here in the case of this ionic compounds, since there is a strong force of attraction, to melt that ionic compound or to change that solid into liquid, we have to break that force of attraction. Then only that force will break and these ions will move. And since that force of attraction is very strong, we need more energy to break that force of attraction, or we have to heat for a long time. Then only that strong force of attraction between the ions will be broken, and that is changing into liquid substance. Okay, so we can tell that these ionic compounds are having high melting and boiling point. Okay, the next property we have to study is their solubility in water. When a substance is dissolving in water, in the case of an ionic compound, we can take as an example, we can take sodium chloride. This sodium chloride is dissolving in water when this positive and negative ion is breaking and they are getting separated. Then only that substance will dissolve in water. Okay. So when we are adding the sodium chloride in water, water molecule is helping to break the strong force of attraction between positive and negative ion, and as a result they will get separated. As a result, this will dissolve in water. Okay. So we can tell that these ionic compounds are soluble in water because the water molecule is breaking the force of attraction between positive and negative ions present in that ionic compound, and as a result that will dissolve in water. Okay. The last property we have to study is conduction of electricity. When a substance conducts electricity, if a substance contains either positive or negatively charged particles, then only that substance can conduct electricity, isn't it? But here, in the case of this ionic compounds, we can see that they are conducting electricity only in the molten state or in aqueous solution. Molten state means after melting, we are getting liquid form of ionic compound, isn't it? That is known as molten state of ionic compounds. And in aqueous solution means when we are dissolving these ionic compounds in water, that is known as its aqueous solution. So, if the ionic compound is present in the molten state or in aqueous solution, it can conduct electricity. But in the solid state, these ionic compounds are not conducting electricity even though it contains positive and negative ions. What will be the reason for this? It is because already we have studied that in ionic compounds, in the solid state, there is a strong force of attraction between the ions. And these ions are very closely packed due to that force of attraction. So there is no space between the particles. And these ions cannot move. Okay. So like that very tightly they are packed and they cannot move. And as a result they cannot conduct electricity. Okay. These ionic compounds, these ions should move. Then only that movement of ion is known as electricity, isn't it? But here in this ionic compounds, since these ions are very closely packed, they cannot move. There is no space between them, so they cannot move. So they cannot conduct electricity in the solid state. But when it is present in the aqueous solution, already we have studied that water molecules are breaking the force of attraction between the ions and they are moving. They start moving, isn't it? So, when these ionic compounds are present in aqueous solutions, these ions are capable of moving, so they can conduct electricity. Like that, when it is present in molten state, after melting, that liquid form of ionic compound, it also can conduct electricity. It is because in molten state, the force of attraction between the positive and negative ions broken. Okay. We are heating that solid ionic compound and using that heat energy, the force of attraction between the ions are breaking. And as a result, the ions are capable of moving, so it can conduct electricity in the molten state also. Okay. So we can tell that these ionic compounds can conduct electricity in molten state and in aqueous solution, but it is not conducting electricity in the solid state. Okay. So these are the properties of ionic compounds. First property, it's a physical nature, they are hard solids. Then second property, melting and boiling points. They are having high melting and boiling point due to the strong force of attraction between the positive and negative ions. Then their solubility in water. Ionic compounds are soluble in water because in presence of water, the force of attraction between the ions will break. As a result, they will dissolve in water. Okay. Now, fourth one, conduction of electricity. These ionic compounds can conduct electricity in the molten state and in aqueous solution. But in solid state, they are poor conductors of electricity. Okay. So these are the properties of ionic compounds. With this, our third lesson completed. Okay. I think it is clear for all of you. If any doubt, you can call me. Okay.